This lecture video will be on section 3.5, and we're going to be taking a look at the equation of lines today. So there are two different forms that we need to know for this section. The first form is the point slope form right here, and it's y minus y1 equals m times the quantity x minus x1. So the y and the plain old x, so these two are the y and the x that show up in this slope-intercept form. The y with a little 1 and the x with a little 1 are coming from some point that the line passes through. The other form is this slope-intercept form, y equals mx plus b. In this equation, m is equal to the slope, and b is our y-intercept. So b is the place where this graph will be crossing our y-axis. And remember, the slope is rise over run. And we can also think of slope as y2 minus y1 over x2 minus x1, where the line passes through the points x1, y1, and x2, y2. So we'll take a look at that another time as well. So the first thing that we're going to do is we're going to use the slope-intercept form to graph some lines. So our first example is y equals 1/2 x minus 3. So our b for this one is negative 3. So this is our y-intercept. And this is where the graph will be crossing our y-axis. So we can put a dot on the y-axis at negative 3. So that's the point 0, negative 3. And then we have our slope, m, is 1/2. And so now remember, the numerator is our rise, and the denominator number is our run. So rise means you go up or down, and run means you go right or left. So when you have a positive slope like we do in this case, 1 over 2, we're going to go up 1 and to the right 2. So from our point 0, negative 3, we're going to go up 1 and right 2. So that will give us the point 2, negative 2. And then from that new point, you can go up 1 and right 2 again, and you can keep on plotting points this way. So we could go right 1, up 1, right 2 again. And so that gave us two new points, 4, negative 1, and 6, 0. And you really just need 3 points in order to graph a line. Now we could have gone from 0, negative 3, and we could have gone in the other direction, but then you would need to remember to do negative 1 over negative 2. So we would go down 1 and left 2. And that would bring us to the point negative 2, negative 4. So you can go either direction. You just have to be careful of your signs when you're doing this. On our next one, we have y equals negative 1/4 x plus 2. So our y-intercept b for this one is positive 2. And our slope, m, is negative 1/4. So now remember, there are three ways for us to think of a negative fraction, and that's negative sign in front of the fraction like we have here, or we can think of it as negative 1 over positive 4, or we can think of it as positive 1 over negative 4. So, and again, remember, the numerator number is our rise, the denominator number is our run. So we'll put our y-intercept on the graph at positive 2. So that gives me the point 0, 2. And then we can either go down 1, right 4, giving us the point 4, 1, or we could go up 1, left 4. Giving us the point negative 4, 3. And 3 points is enough, so we can stop there and graph in our line. Make sure when you're graphing that you also remember to label the points that you are plotting. That's going to be really important. Now on our next example, we have y equals negative 4x. So notice there's no plain old number here. We could write a plus 0 though if we wanted to. And so b for this one is 0. And that's our y-intercept. So put a dot on our graph at y equals 0. So that's the point 0, 0. And then our slope m is negative 4. And remember, we can write any number as a fraction. So we could think of this as negative 4 over positive 1, or we can think of it as positive 4 over negative 1. So if we think of it in the first way, negative 4 over positive 1, then that would mean to go down 4 and right 1. That would give us the point 1, negative 4. Or from the 0, 0 point, we could have gone up 4, left 1. And that would give us the point negative 1, 4. And again, that's 3 points. That's all we need to graph a line. In our next example, we have 5x plus 2y equals 10. So when I have a line in this form, I would typically just plot the intercepts instead of rewriting it. But this section is kind of about using the y-intercept and the slope to graph, so we'll go ahead and rewrite the equation. So we want to rewrite this so that we have it in the form y equals, and so we want to solve this equation for y. So the first step in doing that would be to subtract 5x from both sides. That will give us 2y equals negative 5x plus 10. And then we need to divide everything in the equation by 2. So we get y equals negative 5 halves x plus 5. So b for this one is 5. That's our y-intercept. And then our slope is negative 5 halves. So we can put our y-intercept on there at 5. So that's a 0.05. And then from there, we want to use our slope, negative 5 halves. So we can go down 5, right 2. That will put us at the point 2, 0. And then you can keep going in that direction. In fact, that's what I'm going to do, because if I try to go up 5 from my 0, 5 point, I'm going to be off my graph, so I don't want to do that. So I'm going to continue going in the same direction. Down 5 more, and then right 2. And so that puts me at the point 4, negative 5. And then we can draw in our graph. In the next examples, we want to write the equation of the line with the given slope and y-intercept. So remember, our form is y equals mx plus b. And so we're given our slope. So we're going to write y equals, our slope is negative 9, so it'll be negative 9x. And then our y-intercept b is 4, so plus 4. In our next example b, we have a slope of negative 2/3 and a y-intercept of 7. So our equation will be y equals negative 2/3 x plus our b, which is 7. The next one, we have a slope of 0 and a y-intercept of 1/2. So we'll have y is equal to 0x plus 1/2. 0 times anything is 0, and so this would just be the equation y equals 1/2. Okay, so that is a horizontal line. In the next one, our slope is negative 5 halves, and our y-intercept is 31 halves. So we have y equals negative 5 halves x, and then plus our y-intercept, 31 halves. Next, we want to find an equation of each line with a given slope that passes through the given point, and write the equation in the form ax plus by equals c. So here a, b, and c are integers, so we just can't have any fractions in our final answer. So we are given our slope and a point that the line passes through, so now we're going to use the point slope formula. Y minus y1 equals m times the quantity x minus x1. So remember, y1 is the y coordinate of the point that the line passes through, and this x with a little 1 is the x coordinate of the point that the line passes through. So we're going to have y minus, the y coordinate is 5, equals m, our slope, which is 4, times x minus the x coordinate, which is 10. Now we want to simplify this. In order to simplify, we need to distribute the 4. So that'll give us 4x minus 40 on the right side. And we want it in this form, ax plus by equals c. So we need both of the terms with variables on the left and the plain old number on the right. So I am going to subtract 4x from both sides. That will give me negative 4x plus y. Minus 5 equals negative 40. And then we want to add 5 to both sides. So we get negative 4x plus y equals negative 35. Next example, we have a slope of negative 7/9 and a point 5,2. So again, we're plugging into this equation y minus y1 equals m times the quantity x minus x1. So we're going to have y minus, the y coordinate for this one is 2, equals our slope, which is negative 7/9, times x minus the x coordinate is 5. So we have y minus 2 equals negative 7/9 x plus, so negative 7/9 times 5 is positive 35/9. So before I go any further, I'm going to get rid of my fractions, because in this point slope, or this standard form, ax plus by equals c, we don't want any fractions. So I'm going to multiply everything in this by 9. So we'll have 9y minus 18 equals negative 7x plus 35. Okay, now that I don't have any fractions left, I'm going to get the x term over on the left with the y term, so add 7x to both sides. So we get 7x plus 9y minus 18 equals 35. And then the last step would be to add 18 to both sides. So we get 7x plus 9y equals 53. Okay, the next two examples, we have a slope of negative 6, and it passes through the point negative 8, negative 10. So if you wanted to, you could pause the video right now and try this one on your own, and then start the video back up and see if we come up with the same answer. So again, we're using y minus y1 equals m times the quantity x minus x1. So we'll have y minus, now our y coordinate is negative 10, equals our slope, which is negative 6, times the quantity x minus our x coordinate, which is negative 8. So y minus a negative 10, remember this is plus, so that would be y plus 10. Same thing happens here. This is negative 6 times the quantity x minus a negative 8 is the same as plus 8. Now we want to distribute our negative 6. So we'll have y plus 10 equals negative 6x minus 48. And then we want to add the 6x to both sides. That gives us 6x plus y plus 10 equals negative 48. And then subtract 10 from both sides. So our final answer is 6x plus y equals negative 58. And then the last one of these, we have a slope of 1/2, and it passes through the point negative 4, 8. So again, we're using y minus y1 equals m times the quantity x minus x1. So that's going to be y minus 8 equals 1/2 times the quantity x minus a negative 4. Y minus 8 equals 1/2 times x minus a negative 4 is plus 4. And then we need to distribute the 1/2. So y minus 8 equals 1/2 x plus 2. And then we could multiply everything by 2 right now because we don't want this fraction. We need to get rid of that fraction. So that would give us 2y minus 16 equals x plus 4. And then subtract x from both sides. And we get negative x plus 2y minus 16 equals 4. And then add 16 to both sides. And that gives us negative x plus 2y equals 20. So now in these next examples, we're going to be finding the equation of the line that passes through each pair of points and writing the equation in standard form, ax plus by equals c, the same form that we were using before. So before we were always given the slope, now we're not given the slope, so we need to find that first. So the slope of a line is y2 minus y1 over x2 minus x1. So we're going to take 5 minus a negative 4 over 0 minus a negative 7. And 5 minus a negative 4 is 5 plus 4, so that gives us 9. And 0 minus a negative 7 is 0 plus 7, so that's 7. And the nice thing about the 2 points that I was given is that 0, 5 is actually our y-intercept, and so we can just write out y equals 9/7 x plus 5. And so this is the y-intercept. And so that's why I'm able to do that. And so now I need to multiply everything by 7 to get rid of my fractions. So that'll give me 7y equals 9x plus 35. And then we need to subtract the 9x from both sides. That gives me negative 9x plus 7y equals 35. Our next one, we want to write the equation of the line that passes through 3, 7 and negative 2, negative 6. So again, the first step is to calculate our slope. That's y2 minus y1 over x2 minus x1. Negative 6 minus 7 over negative 2 minus 3. Negative 6 minus 7 is negative 13. And negative 2 minus 3 is negative 5. So that's positive 13/5. Remember, a negative divided by a negative is positive. Now we want to plug this into our slope. Well, we could do the slope-intercept form or the point-slope form. Y minus y1 equals m times the quantity x minus x1. So y minus, and I'm always just going to use the first point here. You could use either the 3, 7 or the negative 2, 6. It doesn't matter. I'll always just use the first one in class, unless for whatever reason the other point is easier. Like in the first example, 0, 5 was the intercept, and so I just went ahead and used that. So that's going to be y minus 7 equals our slope, 13/5, times the quantity x minus 3. So now I need to distribute the 13/5. We get y minus 7 equals 13/5 x minus 39/5. And we don't want fractions in our final answer because we want it in standard form, so I'm going to multiply everything by 5 right now to get rid of my fractions. So I will have 5y minus 35 equals 13x minus 39. So now we want to gather up the variables on the left and the plain old numbers on the right. So subtract 13x from both sides. We get negative 13x plus y, 5y, minus 35 equals negative 39. And the last thing is to add 35 to both sides. So we get negative 13x plus 5y equals negative 4. The next example, it's passing through 9, negative 9, and 6, negative 5. So again, the first step will be to calculate our slope. So y2 minus y1 over x2 minus x1. So that's going to be negative 5 minus a negative 9 over 6 minus 9. So minus a negative, remember, becomes plus. So negative 5 plus 9 is 4. And 6 minus 9 is 3. So we get a slope of 4/3. Sorry, it's negative 3. So negative 4/3. So y minus y1 equals m times the quantity x minus x1. That will be y minus a negative 9 equals our slope, negative 4/3, times x minus the x value, which was 9. So y minus a negative 9 is y plus 9. And then we want to distribute this negative 4/3. So negative 4/3 x, and then plus 36 over 3. And now we want to get rid of all of our fractions. So we're going to multiply everything by 3. We could simplify this, but we're going to multiply by 3 anyways, so it doesn't really matter. So we'll have 3y plus 27 equals negative 4x plus 36. Now we want to gather up the x and the y together, so add 4x to both sides. So we have 4x plus 3y plus 27 equals 36, and then subtract the 27 from both sides. And we get 4x plus 3y equals what is that? Is that 9? Okay. So now our next one, it's going to be passing through the points negative 1/2, 3/4, and negative 5/2, 1/3. So first calculate our slope. M is y2 minus y1 over x2 minus x1. So that'll be 1/3 minus 3/4 over negative 5/2 minus a negative 1/2. So now remember, we need a common denominator in order to subtract. We already have that in the denominator, so that's nice, but in the numerator we need a common denominator. And so our common denominator will be 12. So 1/3 is the same as 4/12, and 3/4 is the same as 9/12. And 4/12 minus 9/12 gives us negative 5/12. And remember, minus a negative is plus, so we have negative 5/2 plus 1/2, and so that would be negative 4/2. So now we have negative 5/12 divided by negative 4/2, so that would be times a negative 2/4. And so now 2 goes into itself once and into 12 6 times. And so we have a negative times a negative, so it's going to be positive 5/24. Y minus y1 equals m times the quantity x minus x1. So that's going to be y minus 3/4 equals 5/24 times x minus a negative 1/2. So that'd be y minus 3/4 equals 5/24x. And then this is plus 1/2, so that would be plus 5/48. So now we should get rid of all of our fractions. So we'd have to multiply everything by 48. So 48y minus 48 divided by 4 is 12, and then 12 times 3 is 36. And then 24 goes into 48 twice, so that's going to be 10x, and then plus 5. So now subtract the 10x from both sides. We get 48y, negative 10x plus 48y minus 36 equals 5. And then the last step, add 36 to both sides. So we get negative 10x plus 48y equals 41. Next we have vertical and horizontal lines. So for vertical lines, it's always going to have the form x equals a, and for horizontal, it'll be y equals b. Okay, so vertical lines have a slope that's undefined. And horizontal lines have a slope that's 0. So we want a vertical line through the point 0, 5. So vertical is x equals, and you can just write it as x equals whatever the x coordinate is, which is 0 in this case. So you don't need to do any more work than that. So vertical is x equals, and it's the x coordinate of the point that it passes through. Horizontal line is in the form y equals, and so it's going to be y equals whatever the y coordinate is of the point that it's passing through. So this horizontal line is passing through the point 4, 3, and so it would just be y equals 3. In the next examples, we want to find the equation that's parallel to y equals 10. So if it's parallel to y equals 10, that means that it is also going to be a horizontal line, and so it will also have the form y equals, and it'll be y equals the y coordinate of the point that it's passing through. It's passing through the point 1, 2, so it's going to be y equals 2. In the next one, we want perpendicular to x equals 2. So if you have a vertical line, x equals negative 2. Perpendicular to that would be horizontal. So this is horizontal, which has the form y equals, and it's going to be the y coordinate of the point that it passes through. And since it's passing through negative 7, negative 1, the equation will be y equals negative 1. Next we have a couple of application problems. So a web-based t-shirt company has learned that by pricing clearance sale t-shirts at $6, sales will reach $2,000 t-shirts per day, and raising the price to $8 will cause the sales to fall to 1,500 t-shirts per day. Assume that the relationship between the price and the number of t-shirts sold is linear. Write an equation describing the relationship. Write the equation in slope-intercept form. So first of all, there are 2 points given in this problem. The first one is at $6, you're going to sell 2,000 t-shirts in a day. So that's the point 6, 2,000. And then at $8, you're only going to sell 1,500 t-shirts. So that's another point, 8, 1,500. So now that we have the 2 points, we can find the slope. So that's y2 minus y1 over x2 minus x1. So that would be 1,500 minus 2,000 over 8 minus 6. So negative 500 over 2, which is negative 250, is our slope. And then plug into the point slope formula. Y minus y1 equals m times the quantity x minus x1. So that would be y minus, and you could pick either of those 2 points. It doesn't matter. I'm going to use the point 6, 2,000. You could use the point 8, 1,500. We should come up with the same answers no matter which of those 2 points that we pick. Alright, so y minus 2,000 equals our slope, negative 250, times the quantity x minus 6. Distribute the negative 250. So we get negative 250x plus 1,500, and then add 2,000 to both sides. So we get the equation y is equal to negative 250x plus 3,500. Next, we want to predict the daily sales of t-shirts if the price is set at $7.50. So our price is the x value, and we want to predict the sales, which are our y values. So we want to replace x in our equation that we found in part A with 7.5. So negative 250 times 7.5 plus 3,500. So negative 250 times 7.5 gives us negative 1,875 plus 3,500, and we get 1,625 t-shirts per day. Okay, and our next word problem. A certain chain of bookstores is slowly closing down stores. Suppose that in 2006 there were 3,991 stores, and in 2010 there were 3,200 stores. Write an equation describing the relationship between time and the number of store locations. Use the ordered pairs in the form years past 2006 and the number of stores. So, if you are in the year 2006, then you are not past 2006, so that's going to be 0. And the number of stores that there were 3,991. So that's 1 point. And then the other point is 2010, so that's 4 years past. So that would be 4 and 3,200. So now we need to calculate our slope. y2 minus y1 over x2 minus x1. 3,200 minus 3,991 over 4 minus 0. So in the numerator we get negative 791, and in the denominator we get 4. And so this is negative 197.75. And you can write this as a decimal when you're doing these in word problems. And a nice thing about this point is that it is our intercept, so we can write out our equation right away. Y equals our slope, negative 197.75x, plus our y-intercept, which is 3,991. Now use this equation to predict the number of stores in 2018. So number of years after 2006 is our x value, and the number of years 2018 is beyond 2006 is 12. So we want to plug in 12 for x. So that will give us negative 197.75 times 12 plus 3,991. So that's negative 2,373 plus 3,991. And we get 1,618 stores. Okay, I think that's it. So I hope you're all having a great day, and let me know if you have any questions, and we'll